Alright, so I think I'm recording. Let's take a look at problems 5 and 6. It's asking me to look at this function and determine the intervals over which the function is increasing, determine the intervals over which the function is decreasing, determine the intervals over which the function is constant, and also to determine whether the function is an even or odd function. When we look at this graph, it looks similar to an absolute value that's been widened and lowered, so a horizontal stretch and lowered 4 units. We can assume that that goes on forever in both directions like that. Let's use a green highlighter to indicate where the function is decreasing and a yellow highlighter to indicate where the function is increasing. As we enter the graph from the left, that arrow is giving us two pieces of information. It's giving us information about the x's and at the same time information about the y values. The x values going off to the left are going to negative infinity, and going off to the left, as you go up, the y coordinates are going to positive infinity. As you're moving to the right, this arrow tells you two pieces of information, that the x's are going to the right towards positive infinity, the y values are going up towards positive infinity. Alright. So as we come in, we hit this arrow. As we're moving to the right, we're going down. So as x is increasing, because I'm moving to the right, I just went through x is negative 7, negative 6, negative 5. That's increasing. But the y values, you can see, are going down until I hit this point that's the vertex that's here on the y-axis. And then it changes. As I move to the right, I have to be moving up to stay on the graph. The y values are increasing. Alright, so if we describe the interval over which the function is increasing, let's come down and look at this vertex. It has an x coordinate of 0. Now, the y coordinate, it's down negative 4, but remember, for locations, for my answers on the intervals over which anything is happening to the function, increasing, decreasing, constant, I'm using the x values to describe that interval. So here, 0, and any 2 points in the region that we've shaded in yellow, if their x coordinates are bigger than 0, as x increases, y will also increase. So from x to 0 forever, all the way to positive infinity, that'll be true. Now, the function is decreasing. As we enter from the left, we hit that arrow. We know that that arrow indicates that the x values is coming from negative infinity. And as I move to the right, if I pick any 2 points that are in this region that's shaded in green, the x coordinates are less than 0, and as x is increasing, the y's are the y's are decreasing. So from negative infinity all the way to 0, and then I don't see any horizontal portion of the function. So this function is constant nowhere, or never constant, or if you're describing an interval, it's the empty set. There is no interval over which the function is constant. Let's take a look. Oh, and because the right hand side is a mirror image of the left hand side with respect to the y-axis, this is an even function. Alright, let's take a look at problem number 6. This is going off the graph, so the pattern here is indicating to me that that's going on forever, like this, and that arrow is giving us two pieces of information. It's giving us information about the x's and information about the y's. Over here, the same thing. Information about the x's, information about the y's. We'll use a yellow highlighter to indicate increasing. As we enter the graph on the left, as we move from left to right through the graph, we're increasing until we hit this point, and then we are decreasing until we hit this point, and at that point we are constant. As we're moving to the right, the y values are not going up or down. The y values are remaining constant until we come to this point. Then we increase for a very short while until we hit this point, and then we decrease. So we have two intervals to describe over which the function is increasing. I've highlighted those in yellow. To give the location of this interval, well, the arrow here, it's negative infinity, and we never have a square bracket. Since positive infinity and negative infinity are abstract concepts, they're really not a real number. You know, we can't find that on the x-axis. It's an abstract idea indicating that the numbers are going on forever without end. All right. Any 2 points in this yellow region, as x increases, y is increasing. That happens to this point, which has coordinates -6, -3. But I'm only interested in the x coordinate. Or union the interval here from this, the x coordinate at this point, which is 5, and well, I'll come back to that. 5, -5, and the coordinates of this point, 6, -4. I'm only interested in the x coordinates. So from x equal to 5 to x equal to 6, pick any 2 points in that region. As x increases, y also increases. The function is decreasing where we've highlighted it in green, and here I need the x coordinate at this point, which is -6, and at any 2 points in this region, as x increases, y is decreasing. To the coordinates of this point, which I haven't written yet, was -5, -5, but I only want the x coordinate, which, hey, I get lucky that even if I accidentally read the y, it's the same. Or union will be over here in this interval. It's in green. The x coordinate at this point is 6, and to the right, since we have an arrow, the x is going towards infinity. This time we finally have a graph that has a portion of the graph that's constant. From the x interval of -5 all the way to an x interval of +5, pick any 2 points that are between -5 and +5, and as x increases, y remains constant. Y is not changing. And now, if we determine whether the function is even, odd, or neither, we have to think about symmetry. Do we have symmetry of the graph with respect to the y-axis, or do we have symmetry with respect to the origin? And if we don't have either one, we say it's neither even nor odd. Let me erase this. I can see that with respect to the y-axis, the right-hand side is a mirror image of the left-hand side. So this is an even function. Alright. Let's see, 1 and 2, 3 and 4, 5. Let's stop there. Hope this helps. Talk to you later.